Hello everyone, welcome back to my YouTube channel. In this particular video, we will be seeing matrix vector multiplication with the help of MapReduce. We already have seen how MapReduce works, what are the important steps that MapReduce performs. Keeping that steps in mind, we will be multiplying these two matrices with the help of an algorithm which MapReduce uses. The algorithm might look weird at the first time, hence I'll be taking this particular example and solve it step by step in such a manner that by the end of this particular video, you will be aware of the algorithm. Let's say we have these two matrices. The first matrix is named as A and the second matrix is named as B. You can see that the first matrix contains the element 1, 2, 3, 4. Now, if you are aware of how to read a matrix, the matrix contains two things. First is the row and second is the column. So let's denote the rows by I for the first matrix and let's denote the columns by J. Similarly, for the second matrix, let's denote the rows by J and let's denote the column by K. Now you might be wondering that why I have taken the same variable j for denoting the column of the first matrix and the row of the second matrix. So the reason behind this is that whenever you are multiplying two matrices, there is a rule that the total number of columns in the first matrix should be equal to the total number of rows from the second matrix. And if they are equal, then only we can multiply these two matrices, otherwise we cannot multiply them. So as you can see, the dimension of the first matrix is 2 cross 2 and the total number of columns inside the first matrix is 2, which is actually same as the total number of rows in the second matrix, which is 2. Hence, we can multiply these two matrices. Now you might be aware that the indexing in the matrix starts from 0. Here we have two columns, hence the indexing will be 0, 1. Similarly, we have two rows, hence the indexing will be 0, 1. Similarly, for the second matrix, we have 0, 1 for the columns and 0, 1 for the rows. Now, if we compile this and create a common matrix which denotes the representation of each element, then it will look something like this. Let's represent a common matrix named as M. So the first element of that particular matrix will be M00 because it lies in the first row and the first column. Similarly, we can have M01, M10 and M11. So this was for 2 cross 2 matrix. Now let's proceed with these steps for multiplying these two matrices by the use of MapReduce concept. So if you are aware that MapReduce performs two major tasks. First task is the map task, which means it converts the entire data in the form of key value pairs. So let's convert the matrix in the form of key value pairs. So according to the algorithm, we'll be performing the following steps. Since we are multiplying two matrices, first let's focus on the matrix 1. Let's say our matrix 1 is named as A. So if you remember, we denoted the rows by I and the columns by J for the first matrix. Hence, according to the algorithm, we need to convert every element of this particular matrix in the form of this key value pairs. The key will be I, k. Here, k is not present inside the first matrix, hence it will be variable. And the value will be a, j, a of ij, which is that particular element. So you can see that I, k is the key and a, j, a of ij is the value of that particular key. So we will have to convert every element of this A matrix in the form of this key value pairs. Now this formula was for the matrix 1. Now we will see the formula for the matrix 2. So it is something like this. The key will be I, k. Here, since I is not present as a dimension in the B matrix, hence I will be variable. Now we will be seeing this concept of variable in the further steps. So the value of this particular key will be the matrix B, J, B of jk. That means the value that is present at that particular position. Here key is I, k and the value is the highlighted one. I hope this particular format is clear. Let's convert each element from these two matrices in this particular format now. Starting with matrix A. So you can see that the matrix A contains first element as 1, which is located at the position A00. So let's write A00. Here the element located at this particular position is 1. Now since this is the first matrix, the dimensions that we are using for denoting the rows and columns for this particular matrix are I and j. So let's denote this A00 as A of ij. Hence I becomes 0 and j is also 0 in this particular case. So now as per the formula, we need to write the first key as I comma k. So we will write 0 comma. Now here in this case, since k is not a parameter which is related to matrix A, hence k will be variable, which means that k will be once 0 and in the other case k will be 1. Now why we are writing this in zeros and ones? Because matrix 2 contains only 2 columns, hence k value will be 0 and 1. So in the first case, we have written I comma k as 0 comma 0, and now it's time to write the value part. Since our matrix is A, hence we are writing A, comma, now j in this particular case is 0. As you can see, j is 0. Hence we will write j as 0, and the third part of this particular value is the value present at that particular index, which is 1. Similarly, we will write for the key 0 and 1, which will be same as the key 0, 0. So I hope this particular part of writing the key value pair of that particular element is clear. Now we will write it for the second element also. So the second element is at the index A01, which is 2. Here in this case, the value of I is 0 and the value of j is 1. For your understanding, I'll be writing here aij, so that you can understand that the value of I here is 0 and the value of j is 1. So let's write the key value pair for this particular element. So in the first case, the value of I will be 0, as you can see here, and the value of k will be differing from 0 to 1. So once it will be 0 and next time it will be 1. And the values for these two keys will be same, which is first it will be a, and now in this case the j part is 1. Hence we will write 1, and next we need to write the value located at this particular index 0, 1, which is 2. So hence we are done with the key value of the second element. I hope you have understood the process. Similarly, we will be converting the next two elements in this particular manner. So the third element is 3, which is located at index 1, 0. Here the value of I will be 1 and the value of j will be 0. Now as you know, the key part is I comma k. In this particular case the value of I is 1, and since k is variable, first it will be 0 and in the next case it will be 1. So this was the key part, and let's write the value for this particular keys. So we are concerned with matrix A, we will write A, comma, here in this case the value of j is 0 and the value that is located at this particular index is 3. Similarly, let me convert the fourth element in the form of this particular key value pairs. As you are aware that the location of the fourth element is 1, 1 and the element is 4. So for the key part, which is I comma k, here the value of I is 1 and k is variable. First time it will be 0 and next time it will be 1. So the value part consists of three things. First it will be A, because this is the A matrix. Next the j value is 1 and the value at that particular index is 4. Similarly, for the next key also we'll write the same value. So I hope this process of converting every element from the first matrix in the form of key value pairs is clear to you all. Now let's focus on the matrix B. The first element of matrix B is 2, which is located at index 0, 0. Note that the variable that we are using for denoting the dimension of the matrix B are j and k. Since this is matrix B, we can denote the first element as B00. Here the value of j is 0 and the value of k is 0. And note that the value that is located at this particular index is 2. Now as per the formula, the key for the matrix B will be I, k. In this particular case, I is not a part of matrix B, hence I will be variable. So it will be 0 once and next time it will be 1. Now the value of k in this particular case is 0. Now let's write the value for these keys. Since this matrix is B, we'll write B. The value of j in this particular case is 0 and the value that is present at this particular index is 2. So hence we are done with the first element. The process is exactly same as we have done for the matrix A, just a difference here is that since I is not a part of this particular matrix, hence the value of I will be variable. First it will be 0 and next time it will be 1. Now let's convert the second element of matrix B in the form of key value pairs. The second element is located at the position 0, 1 and the value at that particular position is 1. So here the I, k value will be 0, 1 and 1, 1 because the value of I is variable. Now the value part contains B, the value of j is 0 and the value located at this particular index 0, 1 is 1. So similarly we will convert the third element which is located at index 1, 0. The element located at this particular index is 5. Here the value of j is 1 and the value of k is 0. So let's convert it in the form of key value pairs. Now since I is variable, first time it will be 0 and next time it will be 1. So 0, the value of k is, here in this case it is 0. So let's write 0 in both the keys. Now in the value part, since the name of this particular matrix is B, so we will write B, the value of j is 1 and the value located at this particular index is 5. Similarly for the next value also, we'll write the same thing. Now let's convert the last element of the matrix B in the form of key value pairs. The location of the last element is 1, 1 and the value located at this particular position is 1. Note that the j value here is 1 and the k value here is 1. Now since I is variable, first we'll write 0 and next time we'll write 1. Now since the value of k here in this case is 1, so we will write 1 in both the keys. Now let's come to the value part. The matrix is B, so hence we'll write B, the value of j here in this case is 1 and the value located at this particular position is 1. Similarly we'll write for the next key also. So now we are done with the conversion of all the elements from the matrix B in the form of key value pairs. So the first part of the algorithm, which was the map task, is completely done. Now after the map task is completed, the next task that is to be performed is the combiner task. Now the combiner task is basically used to combine these key value pairs. As you know that we are dealing with big data, and after converting the entire big data in the form of key value pairs, the volume of this key value pairs is too high that it can cause network congestion. So to reduce that network congestion, we use the combiner task. Now the task is very much simple. We need to focus on all the keys that we have got after conversion of each and every element from both the matrices. Now let's say we are focusing on this particular key 0, 0. So in the entire database, wherever we find 0, 0 as the key, we need to focus on these keys. We need to combine all the values that are associated with these keys in a single block because the key is the same and the values are only different for these keys. So we can combine them and put it in a single block. So for 0, 0, we have the values as A01, which is the first value, and A12 is the second value. So let's quickly write the values for this particular key from the A matrix. Now, once we have written all the values from the A matrix, now it's time to write all the values from the B matrix. First value is B02 and the second value is B15. I hope the process is clear. You just have to combine all the values from the database whose keys are one and the same. So let me quickly write for all the keys. So now here I am writing all the values that are associated with the key 0, 1. Make sure that you are writing it in correct order. Now we will combine all the values that are associated with the key 1, 0. Make sure the order in which you are writing this is correct. Now let's combine all the values which are associated with the key 1, 1 in this particular fashion. Now we are done with the combiner task. Now after the combiner task, the next task is the reduce task, which is a very crucial task. Now you need to perform the reduce task for each and every key. So let's focus on the first key, which is 0, 0. So let's write for 0, 0. Here in this particular reduce task, you need to check the j value of all the values that are present inside this particular key. So wherever you find the j value same, you need to write it one below the other. So in our case, we can see that A01 contains the j value as 0 and the value B02 contains the j value as 0. So hence we are writing this upside down. Similarly, we'll write the values which contains the j value as same, which is 1. Here the values A12 and B15 contains the j value same, hence we'll write it one below the other. Now you need to focus on the third parameter of values which contains the j value same. Here the third parameter contains 1 and 2. So you need to multiply them. 1 into 2 gives out 2 as the answer. Similarly, for the next value pair, we have to multiply the third parameter, which is 2 and 5. So 2 into 5 gives 10. Now whatever result you are getting, you need to add them. So in this case, 2 plus 10 gives out 12 as the answer. Now what is this 12? This 12 is the element which is located at the index 0, 0, because now we are dealing with the key 0, 0. So if our product matrix is denoted by F, so the element located at the F00 index will be 12. I hope you have got this particular reduce task. Now we will perform this particular task for each and every key. So let's focus on the next key, which is 0, 1. As you can see that the values that contains the same j value are A01 and B01. So we will write them in a single column like this. Now the next values that contains the j value same are A12 and B11. We'll write them separately in a single column. Now, as you know, the next step is to multiply the third parameter of these two values, which contains the j value as 0. Now the third parameter is 1 and 1. So 1 multiplied by 1 gives out 1, and from the second value pair, which contains the j value as 1, contains the third parameter as 2 and 1. 2 multiplied by 1 is 2, and when you add these two results, you will get 3. So since we are dealing with the key 0, 1, so the element 3 will be located at the position 0, 1 in the matrix F. Similarly, we'll do it for the key 1, 0. So you can see that the values that contains the same j value, will segregate them and put it in separate columns. So let me quickly do that, and then we'll multiply the third parameter. So now you can see that the third parameter in the first column is 3 and 2. So let's multiply 3 and 2. And in the second column we have the third parameter as 4 and 5. So let's multiply them. So the result of 3 multiplied by 2 is 6 and 4 multiplied by 5 is 20. So when we add them, we get the value as 26. And what is this 26? This is the element which is located at the index 10 in the matrix F. Now similarly we'll perform these operations for the last key. So let me quickly write all the values which contains the same J value in separate column. So here it will look something like this. A03 and B01 will come in one single column and A14 and B11 will come in next column. Now it's time to multiply the third parameters of every single column. So first we have 3 and 1 and next we have 4 and 1. So if we multiply 3 into 1 we get 3 and if we multiply 4 into 1 we get 4, and when we add these two results we'll get 7 as the answer. And now what is this 7? This 7 is the value that is located at the position 1, 1 because we are dealing with the key 1, 1. Now we have performed the task for every single key. Now your final matrix F will look something like this, which will contain dimension 2 cross 2. Now already we have found out the values of all these particular elements F00, F01, F10 and F11. So now it's time to write them in this particular matrix. So as you can see, the values are 12, 3, 26 and 7. So the final matrix F will look something like this. So you can see that the product of the given two matrix is coming out to be this. Now if you guys don't trust me, then let's check the result in this particular website. So let's put the values as per our matrix and you can see that the result is coming out to be this. The resultant matrix also contains the elements 12, 3, 26 and 7, which is exactly same as the result that we have got by using this MapReduce method. So I hope you have understood the entire process of multiplying the two matrices using the MapReduce method. Also, I hope that you have got the algorithm. If you face any difficulties, then you can straight away put it in the comment section. And if you like my videos, don't forget to like, share and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Thank you for watching.